All right, boys and girls, welcome back to the drive-thru. Hope everyone had a wonderful Thursday and you are tuning in from your home. Congrats if you are. You are ahead of the game and you are doing everything you can to stay on top of your goals here in class, including watching the videos at home so you can come to class prepared. That's outstanding. If that's not you, hopefully you're doing the best you can and you got room to improve and you can work towards those things. We're in 7-3 today. Formulas involving polygons. Okay, you're going to learn 3 theorems today, and my guess is that if you wanted to and you took the time to, that at least half of you guys out there could figure at least one of these out for yourself, if not more. Okay, so if you got the time and you're up for the challenge, see if you can figure out the answers to any of these questions. If a polygon has n sides, then what is the sum of its interior angles? You're not going to get an answer. You're going to get an answer with an n in it, okay? Because it depends on how many sides the polygon has. That would make n the dependent variable, okay? If a polygon has n sides, what is the sum of the exterior angles? Think about that. And if a polygon has n sides, how many diagonals does it have? Again, I bet that at least half of you guys could come up with these, okay? But I'm going to do them for you right now. Here you go. All right, so what is the sum of the interior angles of a polygon with n sides? The best way to do this is to make an organized list. So here we're going to have n of sides, the number of sides. And here we're going to just draw a little picture. Here I'm going to write the number of triangles formed. That doesn't make any sense to you yet, so just wait. And then the angle sum will go here. So obviously I've done this before, so I can speed up the process. The smallest amount of sides in a polygon is 3. It looks like that. There is only one triangle there, and the sum of the angles in a triangle are 180 degrees. You already knew all that stuff, okay? So what if we had 4 sides? Okay, well, what I could do is take that quadrilateral and slice it with a diagonal, okay? And what that creates is 2 triangles that are non-overlapping. We basically just took our 4 angles and changed them into 6 angles. Okay, are we allowed to do that? Well, yes, we can, because angle 2 plus angle 3 was just the angle that used to be here, and angle 5 plus angle 6 is just the angle that used to be here. So we haven't added any new degrees, we've just split up the angles. So we can form 2 triangles, and hopefully that's some math we can do in our head. You probably already knew that the sum of the angles in a quadrilateral were 360, but if not, it's official. Okay, pentagon. It's got 5 sides. It looks like that. To draw some non-overlapping triangles, this is one way I could do it. I just took my 5-sided figure and made it into 3 non-overlapping triangles. And this would be 3 times 180, which is 540. This was 2 times 180. This was 1 times 180. Okay, so maybe you're seeing the pattern. 6. We'll do one more. Okay, so if we had a 6-sided figure, we could now do 1, 2, 3 diagonals that would create 4 non-overlapping triangles. This is pathetic. Let me do this right. I'm sorry. 1, 2, 3, 4, 5, 6. 1 diagonal, 2 diagonals, 3 diagonals. There we go. Okay? So that would be 4 times 180, which is 720. So do you see it now? What if we had n sides? I can't draw a picture. I'm going to have to use my list. Well, look, 5 sides had 3 triangles, 4 sides had 2 triangles, 6 sides have 4 triangles. We're going to have n minus 2 triangles. So the sum is equal to, so let's see, the sum of the interior angles of an n-gon is equal to n minus 2 times 180. I hope that if you ever need to know that again, if you don't remember it, you could come up with it on your own. I really believe that you could. Okay? Next, we'll go a little faster now. The sum of the exterior angles, 3. So what I'm going to do here is start with a triangle and then extend. Remember, just one exterior angle each way. Well, let's see. I just got to, what if this was an equilateral? Let's just say it was equilateral. Well, that would be 120, 120, and 120. So we've got sides, picture, this might be it. So 3-sided was 360. Okay. Now I'm going to see a 4-sided one. Well, let's not do a square. Let's do like a parallelogram or something. Okay. So let's say this was 60, 120, 60, and 120. Well, that would make this 120, 60, 120, 60, and that is 180 plus 180, and that sum is 360. Let's try 5. Okay, well, now we better go back to our last page. The sum of the angles of a pentagon is 540. So let's go with 100, 100, 100, 100, and 140. Does that add up to 540? Yes, it does. Okay. Well, that would make this one 80, 80, 80, 80, and 40. 80 times 4 is 320. 320 plus 40 is 360. I got it. The sum of the exterior angles always equals 360, no matter how many sides it has. That's pretty cool. That's pretty cool. I wonder if that's got anything to do with a circle. We'll find that out tomorrow. Okay, and finally, how many diagonals does a polygon with n sides have? Well, I'm going to leave the thinking about how to do this one up to you guys. Okay, so the number of diagonals. I'll give you the equation because it's in your book. But I think it's left for you guys to think about and discover on your own as one of your homework questions, actually a day from now. And that is equal to n times n minus 3 all over 2. So again, I'll leave you to think about that one. So you got 3 equations. You're going to need to memorize them. And if you're not into memorizing, then good for you. You're going to need to learn them so that you can always figure out what they are on a given test day. So let's try an example problem. The sum of the interior angles of a polygon is 1,080 degrees. Name the polygon. Well, I know that the sum formula for the interior angles is equal to n minus 2 times 180. Well, we know this. This is 1080. Start off each by dividing each side by 180. And you get, on this side, it's gone. So you get n minus 2 equals, how many times does, 180 is what I meant. How many times does 180 go into 1080? 5? No, 6? Maybe? Let's just pop my calculator. Okay, indeed, that's 6. So 6 equals n minus 2. So add 2 to both sides. And it says, name the polygon. So that polygon is an octagon. Octagon, octagon, octagon. See you tomorrow. Boom!